The question we'll be answering today is, what is a thread really? So the person who asked this will give us some background, but I really like this excerpt they use from Wikipedia. They say that a thread in computer science is short for a thread of execution. Thank goodness the powers that be didn't go with an acronym here, since there's always acronyms in computer science. Or maybe it was that TOE was already taken. Well, anyways, threads are a way for a program to divide itself into two or more simultaneously running tasks. So I think that concept about simultaneous, or I guess they say pseudo-simultaneous, which is actually a really good idea to say. This idea is associated with threads. So when you think of threads, think about that, a program splitting itself into two things that look like they're running at the same time. But even then, I think I start to mess up by saying it looks like, because threads are really tiny concepts. And very importantly, threads and processes differ from one operating system to another. But in general, threads are contained inside of a process. So this picture I found on a website about POSIX threading, or POSIX threads programming. And I have to avoid the temptation to read all these pages because the purpose of the video is just to go over a Stack Overflow question. But the abstract's pretty good. In shared memory multiprocessor architectures, threads can be used to implement parallelism. Historically, hardware vendors have implemented their own proprietary versions of threads, making portability a concern for software developers. For Unix systems, a standardized C language thread programming interface has been specified by the IEEE POSIX 1003.1c standard. Well, that seems kind of rare, at least to me, in my limited experience. I'd never seen a point number in a letter for a standard before. Well, they say that implementations that adhere to the standard is referred to as POSIX threads, so no mouthful of 1003.1c standards. Just simply say POSIX thread, or if you're cool, P threads. So let's jump to Wikipedia and read what they say in the first few sentences before we dive into the Stack Overflow question and answer. It says in computer science, a thread of execution is the smallest sequence of programmed instructions. I really like that part right there. Now, more details is that it can be independently managed by a scheduler, which is typically a part of an operating system. Thus, earlier them saying that threads are handled by the process or the operating system, I mean. So like everything in tech, it just depends. In this case, it depends on the operating system. But let's read this part and then we're done with Wikipedia. I really like that they say that the threads of a process share its executable code, and the values of its dynamically allocated variables and non-thread local global variables at any given time, so threads are sharing these things. Alright, so let's go over here and we'll go up to some of my mini questions. The first one reads, what is a set of register values? And so when beginning this analysis, I see that the accepted answer has 131 votes, but the one after it is 176. So I'm going to kind of just bypass reading this. And I want to draw your attention to a really good comment, I thought. They said +1 for saying a thread isn't anything more concrete than a set of register values. So if a thread is smaller than a process, one good way to think about it is just this collection of register values at a given moment. These register values are accessed by some sort of control flow, like through a function call, a loop, or a goto. An instruction pointer belongs to a particular thread, and that's what that control flow is utilizing in order to flow. So our first answer is threads are basically a set of register values. Now, what did I say I liked over here? Well, the idea that threads share variables. Now, specifically, it's dynamically allocated ones and non-thread local global variables, but I'm just going to summarize for simplicity's sake and just take this note down by saying threads share variables. Something worth remembering, I think. I also want to take note of that standard name and number just because it's cool. Okay, next question is, which picture is most helpful? Well, I should read the most upvoted question before that, so here we go. A thread is an execution context, which is all the information a CPU needs to execute a stream of instructions. Suppose you're reading a book and you want to take a break now, but you want to be able to come back and resume reading from the exact point you stopped. One way to achieve that is by jotting down the page number, the line number, and word number. So your execution context for reading a book is 3 numbers. Now if you have a roommate and she's using the same technique, she can take the book while you're not using it and resume reading from where she stopped. Then you can take it back and resume it from where you were. Threads work in the same way. A CPU is giving you the illusion that it's doing multiple computations at the same time. So here I go with a summary of that analogy I read. Remember, a big part of this Stack Overflow series is for me to demonstrate to students how I would approach a website like this and the strategies I would use to internalize the information and make the website valuable. Okay, so the last question I had asked was all about which picture is most helpful. So I answered the first question, then took a bunch of notes. Here's the second question answer. Here I've taken you to the first picture, which we see this is from the Wikipedia page actually. You have a visual of a circle. This is the process. Time will flow in that direction, and a thread may be here, then it seems to stop. Thread 2 begins, and then thread 1 starts again when thread 2 ends. So you can either say this picture is valuable, or for me, I just really like this one. Here we have a process, and a process will have a state. The program counter, the stack pointer, the use of a code segment, data segment, the heap and the stack, like the values. But if we're looking at what's called a multi-threaded process, each thread will have a different value. So I say the second picture really connects the idea that a process can be multi-threaded. And so in that sense, maybe a single-threaded process would be like reading a book all in one sitting. The next question says, what is your favorite definition of a thread? Well, that one is so opinionated, I'll just leave you to answer it however you see fit. But let's move to question number 4, where it says, what happens when you double-click Chrome? So now let's better wrap our mind around a process in order to understand the concept of a thread. When we start Google Chrome, there are 3 processes that spawn. You have the browser process, and this is responsible for managing the user interface as well as disk and network I/O. A new browser process is created when Chrome is started, and there's only one browser process created. Another process you have is the renderer. This contains the logic for rendering web pages. Thus, they contain the logic for handling HTML, JavaScript, images, and so forth. And as a general rule, a new renderer process is created for each website opened in a tab. And so several renderer processes may be active at the same time. And the last process we'll study here with Chrome is the plugin process. This is created for each type of plugin, such as Flash or QuickTime in use. Plugin processes contain the code for the plugin as well as additional code that enables the plugin to communicate with the associated renderer processes and the browser processes. So then this person goes on to say that to answer what a thread is, you should first know what a processor is. A processor is a piece of hardware that actually performs the computations. With that in mind, a thread is a basic unit of CPU utilization. It comprises a thread ID, a program counter, a register set, and a stack. Now they provide us with a definition from Intel, which I really like as a source of information. And this kind of brings us full circle to the Wikipedia definition we read at the beginning of this video. Intel says a thread, or thread of execution, is a software term for the basic ordered sequence of instructions that can be passed through or processed by a single CPU core. So I'm sorry, I'm going to use that definition as my favorite definition of what a thread is, especially with all my research on CPU cores and how that works in relation to accessing memory. Yep, I'm going to go with that one. Now notice here I answered number 4 because we kind of moved fast. I moved fast. What happens when you double click Chrome? Well, I just put that there's at least 2 or more processes launching. And then in my own words, I just wrote what we had just read together. So we're 2 questions away from being finished here. The next one says, what 4 items comprise a thread? So now I'm looking for 4 items. And the answer takes us up a little bit to that definition we just read moments ago. A thread is a basic unit of CPU utilization. It comprises a thread ID, program counter, a register, set, and the stack. Now our last question deals with where would we find thread utilization code? So if we look at something as simple as this, adding 1 plus 3 and 4 plus 5 and then adding those two together, Chapter here says that they can fork another process to deal with the 4 plus 5 while the original process is dealing with 1 plus 3. And this particular answer was inspired by the book Operating System Concepts by Abraham Silberskatz, Peter Bear Galvin, and Greg Gagn. So you can go in so many different directions with an answer to a question like that. My answer is from super simple math to operating system kernel building. That was it for this video. I hope you feel better about the answer to the question, what is a thread really?